Hello, today we are doing chapter 5, section 2. Our essential question is, how can you use substitution to solve a system of linear equations? So, if I were taking notes, I'd probably pause and make sure I get these 3 steps down. I'm going to kind of go over them. You want to, step 1, solve for one of the equations for one of the variables. What that means is you want to have x equals or y equals. Step 2, you're going to take that equation and substitute it in for that variable into the other equation, and then you are going to solve. I think it makes more sense when you actually see some examples done. So let's go ahead and do one. So on this one, we've got y equals negative 2x minus 9 and 6x minus 5y equals negative 19. We're lucky on this one because we already have a y equals. That y is solved for. And what I'm going to do is I know y is the same thing as negative 2x minus 9. I'm going to substitute it in for this y right there into the other equation. So when I do that, I'm going to get, I start with 6x minus 5y. I'm going to take out that y, and I'm going to put in negative 2x minus 9. And what you notice is I've got one equation with just one variable. We spent a lot of time, semester 1, solving. So I'm going to solve for that x. I distribute. Combine my x's, subtract 45, divide by 16, and I get x equals negative 4. Well, now I know half of my solution. I know what x is. I need to know what y is. I'm going to take that value and plug it into either equation 1 or 2. It doesn't matter which one you do. One is usually easier than the other, though. So I'm going to put it into equation 1. Because y is solved for, and y is what I'm looking for. And I'm going to get negative 2x minus 9, take out that x, put in negative 4, and you get negative 1. So my solution is negative 4, negative 1. Whenever you give answers, it's always going to be as an ordered pair, x first, then your y. If I wanted to verify that, I could plug that back into both equations and check it. All right, so I'm going to get you started on these, and then I'm going to have you finish them off. Here, well, that y is already solved for. You notice y is solved for here. So what I'm really going to be doing is setting those equal to each other. So 3x plus 14 equals negative 4x. No variable solved for here, but here y is solved for. So I'm going to take that and plug it in for y. So I'm going to get 3x plus 2. Take out that y and put in 1/2 x minus 1 equals 0. In here, I'm going to take my x value, and I'm going to substitute it in right there. So it would be 4 parentheses 6y minus 7, close parentheses, plus y equals negative 3. Take a second, solve those, check your answer. You should have gotten negative 2, 8, 1/2, negative 3/4, and negative 1, 1. Let's do one where one of the variables is not solved for. This is kind of a pain in the neck, but it's still, substitution still works. So what we need to do is choose one of these variables to solve for. I could solve for that x, that y, this y, or this x. I'd probably not do the x down in equation number 2 because there's a coefficient of 3 on front. And that means I'd have to divide everything by 3. And I'm going to have fractions, and if at all possible, I like to avoid fractions. I'm thinking I want to solve for this y right here. I'm thinking that's going to be the easiest. I just need to add x to both sides. So all I did was plus x plus x. So here I have 3 plus x. That's the same as x plus 3. So now, oops, sorry about that. Now one of my variables is solved for. I have y by itself. I'm going to substitute that into equation number 2. So I'll take out that y and put in x plus 3. Combine my like terms, subtract 3, divide by 4, and I get x equals -1. So there's half of my answer. I need to know the y value. So I'm going to substitute -1 back in for x. We're doing it in equation 1, but it doesn't really matter. Be careful of your signs because it's going to be negative, negative, which is going to make that a positive. Subtract 1 from both sides, y equals 2. So your solution is -1, 2. Tell you what, I'm going to get you started on one of these, and I'll let you try the other ones on your own. So on this one, I'm going to solve for this y right here. So that means I need to subtract x from both sides. And when I do that, I'm going to get y equals -x minus 2. I'm going to take that and substitute it in for my y value into the second equation. So -3x minus x minus 2 equals 6. Go ahead, hit pause. Try all of these. Let's see how you do. The answer for number 4, it's kind of covered up, but it should be -2, 0. Because you're going to end up, do this down here, combine your like terms, and you get -4x minus 2 equals 6. Add 2 to both sides. Divide by -4. X equals -2. Then I plug that back into the first equation. -2 plus y equals -2. Y equals 0. That's where that -2, 0 comes from. For number 5, I probably would have solved for this y by adding x to both sides. So y equals x minus 4. Substitute it in right here. So when you substitute that in, I'm going to get fancy here for a second. You want to put parentheses around that because you need to subtract that whole thing. So make sure you distribute that negative sign. So it's really 4x minus x plus 4. Number 6, your answer should have been 6/17. On that, I would have taken that first equation, 2x minus y equals -5. Subtract 2x from both sides. And then I would have divided by -1. So y equals 2x plus 5. I would have then plugged that into the second equation. And again, you need to be careful of those signs because you're subtracting that whole expression of 2x plus 5. And on the last one, you should have gotten -2 9/2. And if I look at what variable, I would have solved for that x in the first equation because that's the only one that has a coefficient of 1. So we started off with x minus 2y equals 7. Add 2y to both sides. You get 2x plus 7, and then you would have put it into this value of x, so 3 parentheses, 2x, I'm sorry, that's not x, I went from x to y, that's a y, 2y plus 7, and then you don't want to forget your minus 2y equals 3. And then you can go ahead and solve it from there. I'm going to make that y look a little bit better. It's a sloppy mistake that can screw you up. And when you solve for y, you're going to get -9/2. Plug that back in, solve for x, and you get -2. Let's go ahead and do a word problem. A drama club earns $1,040 from a production. 64 adults and 132 student tickets are sold. An adult ticket costs twice as much as a student ticket. So we want to write a system of linear equations that represent this situation, and then we want to find the price of each one. So we got two things that we're looking for: adult and student tickets prices. So my plan is I'm going to get a system of equations and then solve. So let's go ahead and solve that. 64 adult plus 132 student is 1040, and the adult ticket is twice the student price. You can choose what variables you want, but we'll let x be the adult and y be the student ticket prices. So there are my two equations. I'm going to use substitution because that x is solved for. Take that equation right here, and I'm going to put it in for x. When I do that, I get 64 times 2y plus 132y equals 1040. Simplify, multiply, and then combine like terms. Divide by 260, and you get y equals 4. So now I need to know x. You double that because x is 2y. X is 8. So there's my solution. An adult ticket costs $8. A student ticket costs $4. I asked myself, does that seem reasonable? And the answer is yes. Hope you enjoyed.